what is EMF? EMF is any device that increases the electrical potential energy, P is potential energy of charges in a E circuit, electrical circuit. Example, batteries have sources of EMF, and generators have sources of EMF. Batteries, it's the chemical potential energy that creates the EMF, and generators is a mechanical energy. Let's say you had some kind of pump, and you were just pumping it. So the formula for this EMF, it just stands for, I believe, the Greek letter. This is the Greek letter. Delta V equals E minus current times resistance. Resistance, this is the current of the circuit. This is the resistance of the battery. Series with resistors. Now there's two types of current. There's two types of circuits, and you can mix them. And this is when you mix them. This is how you create several different types of things in the world. You have computers. You have simple things like cell phone. Not cell phone. Simple things like just a light bulb on the roof. Let's start with series with resistors. Series circuits with resistors. When the ends of these resistors are connected in a circuit, you can see how I drew these resistors. These are the devices that look like this. And one side is how the lines are a little bit wider than the lines on the other side. So you have this side of the resistor connecting to this side of the other resistor. Now you can you can compare resistors to light bulbs. Light bulbs have resistance, but they're not resistors. As you can see, I drew it the same way. This is just point of connection. If you wanted to know, let's say you had 3 resistors, or possibly more. You wanted to add up the resistance. Let's say I had a different value for each one, and you wanted to know the total equivalent resistance. Well, that's simply resistance equivalent equals R1 plus R2 plus R3, as in, or resistor 1 plus resistor 2 plus resistor 3. And you can see that this is all 3 of these is the same thing as this. Parallel is a little bit more difficult, but with practice comes perfection. You have a parallel with resistors. Resistors, as you can see how I drew it here, it's a little bit different than here. You don't have this in you have one side of the resistor and the other side of the resistor. They actually not line up together, and they all meet in one spot. They don't meet. You don't have this point touching this point, and then going through here, and this point touching this point. Is different. They all line up the same way, and they all meet in the same spot. That is parallel. As you can see, they are actually parallel to each other. This is the actual, as you can say, physically you can actually set it up like this. The formula for that is simple too. First of all, you have the inverse of equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3. Now let's say you want to just solve just for R equivalency. Well, you switch, as you know in algebra, you can switch all of this, okay, with this. You can swap the sides. Now, as you can see, I did that. So 1 over all of this equals REQ. REQ equals 1 over R plus 1 over R2 plus 1 over R3. I will go into more depth in this in the next lecture.